So over the next couple days, we are going to look at lesson 26 together about some other kind of derivatives that we have. The first two are going to be ones that we're going to need to see on our calculator. They are ones that are very hard, if not impossible, to do by hand. So we're going to know some things about our calculator. The ones about sine and cosine is something that's going to deal with the graph that our book will help us with. And then eventually, sometime next week, we'll get to the exponential growth and decay. There's a formula that will follow, and we'll be able to stick some things in using some processes that we know to help us solve in a question. So let's go ahead and begin out with our first derivative today, which is the derivative of e to the x. Remember that letter e? It's a natural number, and when I'm referring to natural, I'm not referring to like the positive numbers. We've talked about something before that's with our ln. The ln was the natural logarithm, and that was something that had a base of e in the question. It's used a lot in like engineering physics. Maybe you've seen that in physics already this year, maybe not. The value of the e is approximately 2.71, 2.72, and we're going to notice something about the letter e as we're doing our question. Now, the first time we talked about derivatives, we had that giant formula. It was the limit as delta x approaches 0 of f parenthesis x plus delta x minus f of x all over delta x. Now, a couple lessons ago, I had just briefly mentioned that some calculus textbooks use an h instead of using a delta x, and that is the case here as we're looking at our letter e. So the derivative of e to the x, according to the formula that we've talked about earlier this year, it's a limit. So the limit as h instead of delta x, that limit as h approaches 0, and then here's the formula. The formula that we've talked about earlier this year says f x plus delta x minus f of x all over delta x. So the first thing that I have in the numerator, took my original function of e to the x, and it's replaced the x with x plus delta x, but we're just going to use h on our question here. So x plus h is now in the numerator. Then we're subtracting the original function of e to the x. And then again, originally, normally that's over delta x, but we are using h in our question. When we did these limits before, what was the goal? After we replaced everything into the question, what were we kind of trying to do before we could calculate the derivative? And you remember what that was?
Just simplify it.
Okay, and what are you, as you're simplifying, what are you trying to get rid of?
The delta x.
The delta x. Why do I need to get rid of the delta x that's in the denominator? Because normally the question says this. Why do I need to get rid of that delta x in the denominator? So what is delta x getting close to? 0. Well, I can't have a 0 in the denominator, so as Josiah said, we try to simplify into the numerator to see if there was something that would allow us to cancel the delta x that we had in the denominator of our question. We just learned in previous lessons that if we had some numbers, we can drop the exponent down to the front, subtract 1, and that would give us the derivative as well. Well, I don't want to do that here with e to the x, because it's going to say x e to the x minus 1. That's not really going to help us as we're looking at our question. Now, if we try to approach this like we've done before of trying to eliminate the denominator that we have in the question, eliminating that denominator of h, there's no easy way to do that in the question. I cannot rearrange that numerator so that way there's going to be a factor of h for me to cancel out the h that I have in the denominator. But here's what we're going to do. I do not need you to write the second bullet down, but because we do know for small values of h, that means they're approaching 0. Things that are small are getting closer and closer to 0. That's what a derivative is. We're going to be able to approximate what is the derivative function for e to the x. And we're going to use our calculator to help us do that on the question. So I'm going to put some things up here on the slide. as they come up on the slide, we're going to put them onto our calculator as well. So make sure that you have that out so you can enter some things as we're going along in our question here. So how are we going to figure out this derivative using our calculator? Again, I can't use just basic algebra steps because I cannot get a factor of h in the numerator that's going to factor out the h in our denominator of the question. All right, what I would like you guys to do on your calculator, if you will please press your y equals button up there on the top left of your calculator, and if you will enter this equation underneath y1. Your e to the x button should be on the left-hand side. You should see an ln button, and right above ln, you should see e with an x. So if you will hit that button, usually you have to hit your shift key to get to that. Just the letter E should pop up on your calculator with that little caret, and then you'll need to hit your X. With that alpha key, you can close the parenthesis, and if you'll arrow down to number 2. Okay, so your calculator should look like this if you entered that question correctly. Okay, everyone with me on step number 1, entering in the original function. All right, now what I want to do is compare that original function to its derivative. So on the second line, underneath y2, I'm going to need you to enter this function. Okay, so we're going to start the same way. Go ahead and hit your second ln key, so it puts up the letter E. It should put up a parenthesis already. Is that the case? It gives you a parenthesis? Right. So inside the parenthesis, hit your letter X, like you did the last time. Hit your plus key. Now, in order to get that letter H on your calculator, you should see an alpha button. I think that's in green over there on the left-hand side. Hit your alpha key, and then over on the right-hand side, you should see an exponent key. It's right above the division key. That's where the letter H is on your calculator. So if you'll hit alpha, that green button on most of your calculators, and then the H is right above the division key. It's with that caret-looking key on your question. Everyone see the letter H on your calculator? All right, close that first parenthesis because we're done with the first exponent. Hit your subtraction key. Enter the second thing, like you've done before already. So e to the x. Okay, and I needed you to do one thing, and I forgot this. If you will arrow all the way back to the left-hand side of y2. I need you to insert a parenthesis back here at the beginning because there's 2 things in the numerator. So arrow all the way back to the beginning of y2. Then if you'll hit your insert key, that's above the delete key. So you'll hit second, insert, it should start flashing your cursor. And then if you'll hit your parenthesis button, it should put a parenthesis in there for you. And then arrow all the way over so you're back at the end where we left off with our e to the x. Close your parentheses. You're going to have 2 parentheses side by side right here at the end of the question. Then hit your division key, and then do your alpha with your H, again on the question. So your calculator should look like this. It's going to say E with that little caret, X plus H, close that, minus E, oops, forgot my caret. It's going to say E with your caret, and then, oops, and then parenthesis H, close that one more time, divided by the H. Okay, anyone need to have me help you enter something, or do you want me to look at what you did to make sure that we were good? Actually, let me do that. Let me just peek on your calculator to make sure everything is how I need it to be. Looks good there. Good there. You're going to hit the alpha and then that H key for your question. Oop, I'm sorry. You were fine with what you have there. I'm sorry. I thought you were talking about one of these. I do want the X inside of that first parenthesis because that's e to the x power. I need just one more parenthesis before you hit your division key. And then down your division with your alpha and your there. For right here. crossing that second parenthesis? Yeah, you have x on your second thing, so I wrote h. Yeah, you're good, okay. All right, so what I have, the first function, that y1, is the original function. The y2 is the derivative formula, where I took the original function, replaced the x with x plus h, minus the original function all over the h. So that's our derivative formula that we talked about earlier this year. All right, go ahead and hit for me. I think it's second quit, so you're going to be back on the main screen for me. Okay, so you should be back on your main blank screen. As we are doing derivative questions, right here in the front, it says the limit as either x or delta x approaches what? What number will be sitting right here? 0. Okay, so I need to assign something that my h is getting close to. That way I'm going to be able to calculate the derivative on our question. Okay, so here's what we're going to do. We are going to define on our calculator, if I can get this to come up for you, we are going to assign a small value for the letter h. Now, the small value that we're going to assign for h is this small decimal. I do not want to put 0 in for h, because that would put a 0 in the denominator, and I don't want to put a denominator on our question. Okay, so go ahead and write that down in your notebook, and I'll show you how we're going to enter this onto our calculator here. This is telling me that the h is approaching 0, which is what's happening on a derivative. The limit was approaching 0. Okay, so back on that main screen. If you will type in that decimal for me, so your point that has got 4 zeros, 0.00001. If you will hit, it says STO with an arrow. It is over on the left-hand side of your calculator near the bottom. It's the second button up from the bottom, so we're going to store something into our calculator. Then if you will hit your alphabet H again for me, and your screen should look just like what I have up there on the, so 0.0001 is going to head toward H. The H is going to approach this question on our calculator. Okay? Again, the goal for doing that, the H is approaching 0, which is what we had for the limit on your question. All right, everyone with me so far? Those two things on your calculator. All right, so let's have the calculator do the work for us with actually putting these numbers in for the h and seeing what's happening with our derivative on the question. All right, our next step of the question, we're going to make a table of some values for those y1 and the y2 functions that we originally entered onto the y equals screen. All right, what I need to do on your calculator, go ahead and hit the table setup key. That's the second and then window. So it should be up there at the top. You'll hit your second key and then the window button. So right above that it says table setup. Okay, and on that table setup screen, I need you to make sure that your table start option as well as the delta table are set to 1. If they're not, arrow, so you're next to those options, and if you'll type a 1 into those positions. So both your table start, where I want to start our table that we're going to look at in just a second, and then the change of the table, I want it to go every 1. So our table is going to say 1, 2, 3, 4, and so forth on the question. Yeah, so both of those should say 1 there. Good. You're good. And yours is good. Okay, so that's just giving us some information that's going to help us on our table. All right, so we got everything set up the way that we need it to set up in our question. Let's go ahead and look at that table. So what are these questions approaching as that h approaches the small value of our question? On your calculator, if you will hit your table key, that is above the graph button. So second graph. And it should give you a table of some different values. Notice off to the left-hand side, those are the x's that we assign. Beginning at 1, then it's going up by 1. So it said table start, we started at the number 1. Delta table was the change of the table. I kept going up by 1 every single time. The second column over is y1. We defined y1 as e to the x. That was our original function. y2 was the derivative function, that e to the x plus h minus e to the x all over h in your question. What do you notice about the two tables that you see on the right-hand side of your calculator? So what do we notice about the y1 and the y2? It says error?
Yeah, so does mine.
Huh. Does yours show you a table, Anna? Yours doesn't say error? Okay. Why does it always work when I try it by myself and then I go to try it with you all and it doesn't work anymore? I've got that set up right. You did that. Let me check this. I don't think this is going to make a difference, but let's try that. Nope. Amelia, does yours say error? Yep. What did we not do that we needed? Alright, so what did you do differently, Anna? That we did not do. Is e to the x divided by h. I swear this works, and that was the exact same steps that I did. I even wrote them down as I was doing them into my notes, so I would know exactly the steps I wanted you guys to press. Alright, so let me try this on mine here. E to the x. E to the x plus, h minus e to the x. Oh, e to the x plus h. Close that parenthesis. Minus e to the x. Alright, so I didn't work on my calculator. We all hit the same buttons that I just pressed. No, you did that, right? Let me do this. Okay, maybe it's that. Here we go. Okay, if you got an error, go back to your main screen, so hit second quit for me. Did you hit enter after you hit the letter H, or is your cursor still on the same line as the H?
Cursor's still on.
Hit enter for me. Because it's got to store that number in for the H. That's what it's doing. It never assigned that number to the H. Okay, so now let's go second table. Ta-da! There it is. Okay, why is it not working? I hit the same buttons. Okay, so if you hit, what's your calculator? Start there. So there we figured it out. What do you notice about the two tables that now we see on our screen, where the y1 was e to the x, that was the original function, and then y2 was the derivative function? What do you notice about the different numbers you see in the y1 and the y2 column?
They're exactly the same.
They're exactly the same. What does that tell you then? So the y1 and the y2 columns are equal. What does that tell you then about the original function and the derivative of e to the x? They are equal to each other. Okay? And this is the main thing that we'll focus on today. I was hoping to get to another one, but that's okay. That was painful on the calculator. So the derivative of e to the x is e to the x. The derivative of this natural kind of number is itself. There are very few functions in calculus where the derivative is the same as the original question. Like yesterday on the test, if it said x to the fifth, the derivative was 5x to the fourth. It was a different kind of function. The e to the x function is one of the derivatives where the answer for the derivative matches the original function. That is nothing that we will be able to figure out by hand because we can't use the limit formula by hand, but by looking at the information that we see on our calculator, assigning the y as the original function, assigning the y2 as the derivative function, the h was getting close to 0, which is what's happening on the limit. We notice that I get the exact same answers on our question. So let's do this to finish up for today. This is how we're going to use a question that involves this problem. If I said f of x is equal to 2x to the third plus 6e to the x minus 5. And my job is to find the derivative of that function. Again, the notation for derivative is just the original function with that little tick mark. Sometimes it's written like this, the derivative of y with respect to x. Those are just some different notations that we have for the derivative. The first part of this question is like you did on yesterday's test. So Colin, what's the derivative of 2x to the third?
The 6x squared.
Very good, it'd be 6x squared. We drop that exponent down to the front, multiply, and then we subtract 1 from the exponents of 6x squared. This part of the question is the new part we are focusing on. Because I have the letter E, I do not drop the x down to the front. Notice the ones where we're dropping the exponent down to the front is where the x is the base. The x is now up as the exponent. So what do I do for the derivative of e to the x? Absolutely nothing. It's the exact same as the original question. The 6 does not change, the e to the x does not change. That part of my answer is the same as the original problem that is given to me. The last thing in my question, just my constant, the number 5. What is the derivative of the number 5, Amelia?
0.
It is 0. There is no variable to drop something off of, so that part of the question disappears, and there is the derivative that we have in our question. So again, e to the x, it's one of the few functions where its answer for the derivative is the same as the original function that is given to you on the question. Hopefully tomorrow, I was hoping to get to the second thing today, tomorrow we're going to use our calculator to see what happens on this ln function. The ln and e are tied into each other because ln is log base e. So when I just have e to the x, it's an exponential format. Now we're going to look at tomorrow the logarithm format. What happens with the derivative? It is not the same anymore. Once I hit the ln, that is only true about our e to the x question. The derivative is the same. Okay. Any questions on that concept? So that's one we'll have to memorize, that e to the x is its own derivative. Alrighty, and we